without treatment. So like a countries have a really lacking on the access for the medical care, like in the world map, so in like India and so the Nepal, and for the Southeast Asia, and then we can see the daily rates. So all the Southeast Asia from the orange to the red zone, right? So we need the devices, portable devices, a simple, cheaper, and very accurate, and digitalized. That means to be able to tracking. That means to track when the outbreak is happening. So what the problem with the current system? So as shown right now, the gold standard we call as a wider test. They using a blood to cultures, but they need a complexity and need a time statement for the culturing. And most of the testing is a qualitative method. So what our target in our group? So how the possibilities? They mean to convert from the qualitative method approach to the quantitative method. So as shown in this slide, so if with the blood culture, they take about the 3 to 5 days and have some misdiagnosis between the typhoid fever and that with the other diagnosis fever. So what we are target for our project, how the possibility, the utilize of the electrochemical sensing platform, and then be able to convert the data, that means from the qualitative data to the quantitative data as a current signal, and be able to make it the system be the digital form, so be able to integrate with the IoT, the enable of the IoT system. So we based on that, so we hope that can be more specific and the fast detection. So that can be the earlier treatment. So that can be, we can know which have the outbreak. So it can be, that can be more faster to make the action. That means for the, not only for the detection, but be able to do the monitoring. So what we are propose a method. So as shown in this project is collaborations between my side from the engineering, and then we work with the Institute of Molecular Medicine that from the medical science. So how they come to the engineer the protein and DNA that have a specific, not only for the infection patient, but now we focus on the infection of patient and also with the carrier. In Malaysia, we have some problem for the food handlers, right? So some they have detect as a, but we cannot detect other day as a carrier. So we focus on the two method, two detection, the infection of patient and also for the carrier. Then we do the let I continue for our proposed method. We have a group from the Institute of Molecular Medicine to help us to develop the protein. That means for a probing for the carrier and also for the to detect a carrier and also in the infections. Then in our group, so we develop our own electrochemical sensors using the concept we call as the lab on printed circuit board. So what the uniqueness of the sensors? So we do fabrication using a standard how we do for the circuit fabrications, right? So next, so we do the modifications on the working electrode with the graphene oxide with the chitosan to improve the surface area of the working electrode, so that can amplify the current signals when the probing and the target is matched. So that can be the hybridized, so that can affect the surface area, can reduce the ionization transfers between the target to the electrode, so that reduce the value of the current. That's how we convert from the qualitative to the quantitative data, right? So, and then, so how to minimize the sample? So we do the integrate with the microfluidics. So then we do the integrated with the microfluidic, so that can minimize the sample, so that can be make it the system make it a fast detection with the minimum amount of the sample. Finally, we do the integrations with the our own fabricated microcontrollers, so that may make the system be IoT enabled, so that can be have a Wi-Fi connectivity, and then can be the integrated with the smartphone. So this is what our current prototype. So this is a project, the ongoing project with our group and the industry partner start from Biogenes. So we collaborate with the as a partners. So this shown how we the prototype of the sensors. So how we be able to modify for the readers. So this the app the sense. So how they can be paired with the smartphone. So the Android OS. So the good if so that can be know the GPS. So be able to detect which the detection is happening. So but now so we be able to make to be the system make it as a quantitative. So as on that how this as a current signatures. So that's what we are current prototyping, the current prototyping, and also I say also the video in the system. I mean for the demo of the prototyping. So the good if the impact if for the scientific and the technological, so we develop the highly sensitive quantitative the Salmonella detections in using the electrochemical transducers, and we develop our own design, the own fabrications, and then using the concept of the lab on printed circuit board. Then by modify the working electrode with the carbon-based nanomaterial, we use the graphene oxide and chitosan. So we amplify the signal for the current. And finally, we show how the possibilities for the Salmonella as a IoT. I just call as the Internet of Salmonella things. I mean for the Salmonella point of care diagnosis. For the societal, so when we have the data, so I mean we be able to tracking we have the outbreak is happening. So that means we can do a fast action, fast alert, so that can be for the to a tracking for the at the local communities. For the collaborative, right now we are working with the Institute of the Medicines, from Inform and the MOH, the Ministry of Health, and also with the startup company that mean to do the further prototyping. And then of course we have the engagement through this grant. We have for the previous grant we work through the CREST grant and also with the local community in Kelantan. So that's what the impact. So how we be able to convert from the traditional technique, that means from a blood cultures, from the qualitative data towards to the lab on chip, but we modified to be the lab on printed circuit board with the enable of the IoT, so that can be a further improvement with the cloud analysis. That means for the deep learning analysis. So right now, so our data, we saw the prototype be able to communicate with the Android-based smartphone, and then hopefully that can be more impact. So for example, like for the in the rural area. So this device can park at the rural clinic. That means to have a fast. That means for the typhoid fever monitor. So that one of our current output. That means from the outcome from that fabricated sensors. So we achieve the LOD for the DNA about 0.076 micrometers. So that how the output from the portable MCU. So it means for portable video. So that for the DNA type. So this is what we have for the protein. We have worked with the YNCE and also the hemolysing of protein. So that we have achieved right now with 1.132 microgram per milliliters. So this still in a progress to improvise the sensitivity using the ERS measurement technique. So that the current outcome that we have. So the portabilities of the Internet of Things enable for the Salmonella detections. So the conclusions. So we improvise the miniaturization and the limit detection for the electrochemical sensing for the Salmonella detections. And then we put the concept, our sensor not only detect the infection of patient, but be able to detect the carriers by the engineered the protein with the developed by the Inform. And then by the integration of the IoT system into the biosensor can be promising diagnosis tool for the digital-based Salmonella detection we call as the Internet of Salmonella Things. And then so this platform also can be interchangeably with the other bioreceptors, just do the modifications on the probing. And then as a future work, we hope we can integrate with the cloud services and machine learning to create the prediction system for the behavior of some Salmonella outbreak in local communities. With that, I end my presentation. Thank you.
Okay, thanks. We only have 1 minute for one question, perhaps. Yeah, I already see the hand raised up. Can somebody send the mic?
Thank you very much for the presentation.
Thank you.
So this kind of a lab on a chip device. Is there any way we can convert, because I think currently it's on a micrometer scale. Is there any opportunity if you can convert it or miniaturize it in nano size dimension?
Okay, because that what we are propose, because the target, if you want to propose the cheaper and the simple the diagnosis system, that's why they have the pro and con. So the first, because the lab on chip, is more to the silicon, so it can be able to miniaturize up to the nanometers using the semicon process fabrications. But what our target here is, we want to have a system able the simple but easier to do the fabrication using a standard the printed circuit board. So the uniqueness of my project, we approach on the lab on PCB, lab on printed circuit board. Then to answer your question, I mean, how possibility to miniaturize, is it up to the nano, is still depending how the limitation of the printed circuit board fabrications technologies. And then some sensors because
we gotta take the question outside offline.
Okay.
Yeah. It's getting longer and longer.
Thank you.
You have more things to share. Thank
thank
you
you.
for the presenters.
Right.
Now we welcome the second speaker to come forward for the title of his project, Combining Contourlet Methods and UNet to Segment and Locate Abnormalities on Coronary Arteries Image. Can we have the presenters to come forward? Yeah, okay. Just a reminder to the presenters, when you are excited presenting your work, please also listen to the bell. We actually hit a few times. I think it didn't get through to you guys.
Good afternoon, everybody. I'm welcome from Sai Gon University of Vietnam. So I'm so honored to introduce. This is my project. Is here about total. Is segmentation. This is a coronary artery image and detect. This is abnormalities. This is a branch of a big project about we would like to use a combined controlling method and unit to segment and locate by this is a new algorithm to find out. So it is in 2019 in the world over 17.5 million deaths. This is over 32% in global deaths. It leads the cause of the death in the group is cardiovascular disease. Is it some problem in the vessel in the heart? If we have a problem, this is abnormalities. So we have a accident. Is it right now? Similarly to that, we don't know happen in here. These are reasons. This is come from the hospital. Is it a doctor requires about how can they detect it early by X-ray? If they know it is in the early is by the X-ray image, these are golden standard time they can rescue this pattern. And from the image from the video, they scan this pattern. How can we detect and locate and warning to the doctor where is this is abnormalities, nearly help them to solve this problem. So this is the problem the target. We have two problems. The first from the image, how can we know where is the coronary artery image? This is how we can use some technique or some method to solve by segmentation. The second problem, and we detect the abnormalities to locate these abnormalities on the vessel. So from the problem, we suggest to some method. The problem one, from the vessel from the coronary artery image, it is a contrast. It's the same with the vessel and around the vessel. It's near the heart. So this is a problem. It is difficult to segmentation. So our group to suggest to enhance this is the vessel by control it. After that, we build is a unit. This is a kind of the deep learning. This is improved by CNN to get this is output. This is the image. Coronary arteries is segmented. The second problem we solve by we have a three step in the head. From the input is a problem we detect abnormalities is the output from the segmentation, and we pre-processing and find candidate. Finally, we confirm this is who is the candidate is the abnormality, and we get output. The detail from the problem problem one proposed method, we have a two phase. The first phase we enhance by control it. We use the control it. This is a method to enhance and adjust coefficient and control it and reverse control it transform. We have the result. It's enhanced. The second phase we segment by unit. Unit is deep learning. This is improved by CNN. It is very, very good for medical image to processing. With the second problems, we suggest three phases. The first, we are pre-processing. The first from pre-processing, we smoothing. We make a smoothing the ad. When after we resolve with segmentation, this is a boundary is not instrument. This is a big problem. So we must to make it smoothly. The second, if the vessel is direction is so different. So it's a big problem if we move to from the vessel to vessel on the egg. This we cannot detect what happened inside. So this when we rotate, this is the vessel to horizontal vessel in make easy to solve. The second phase, we detect candidate by we move on the upper and lower there's a boundary, and we find out who is the by the direction and the angle, what is a bit the area is the candidate. And the last phase, we form the candidate, we calculate the diagram, and we confirm who is this where is area we can sure is the abnormality. So this is our research in back to serve abnormality detected by new method. This is a problem come from the hospital. This is the doctor requires to help them to solve this problem. I think it is if we can solve this problem, this is the almost hospital to need to early to detect this is the abnormality. The second, we would like to have a cooperating to collect more data, because you know it is data from the hospital, from the medical. It is very, very important and difficult to get the data, because some license from hospital, license from the government in here. And we can have a cooperation and we can connect to publics together. These are our result, and the hospital can use the result. This is the outcome. It's my project, a new solution. The second, the public data. If we can collect data in Asia, from Vietnam, from Indonesia, Malaysia, Brunei, we can collect it and we publish to researchers over the world can improve. This is more about, and we have a cooperation in Asia to work together. So this is a target. Is it detect the abnormality on coronary artery image? A method we use a form Contourlet combined with UNES and design more about new algorithm to detect. And the third is the scientific and society impact. So this is the problem, and how doctor and how get more about cooperation in Asia. So thank you very much for your attention. This is my email. If you feel is it my project, my topic is it attractive, you can connect me and we work together. Thank you very much.
Thank you to the speaker. While you make a record, we have 7 minutes left for question and answer. So anyone?
Is it also radiation pattern? Three-dimensional also, this one UNEC segmentation?
Yeah, we work at 2 dimension and 3 dimension. Yeah, 2 and 3. Yeah, because if we take a picture, it's a 2 dimension. If we take a video, it's a 3 dimension. But with the 3 dimension, it's more difficult than 2 dimension, because if the patient to go to hospital, they scan, this is the vessel, because the doctor, the hand is not handle is they are flexible. It is a move around. It is some signal and some result is different. Yeah, you.
I have no question. Only one recommend, maybe.
Yeah, thank you.
Because in my opinion, this research is on the medical area. So that I think it's better to have one doctor in your research team, because I think for defining the abnormalities in the image. It's better to have one doctor.
Yeah, thank you very much. As I introduced, this is a problem come from the hospital. So this is the reason is some doctor to help us.
Okay, any more hands?
Okay, thank you very much. I am Hairul from Telkom University, Indonesia. I have two questions. So the first, would you please clarify what is the current method? Yeah, and then the existing method, I mean, and then what is the difference compared to your new algorithm? So this is the first question. And then the second, here you use the two phase, right? Segmentation and detection of the abnormality. So for the detection of abnormality, I think we can use a computer, for example, to detect. But for the segmentations, or both, or you are using computer, image obtained from the doctor, and then you analyze using computer. So this is my question. So please clarify if my question is also wrong. So please clarify. Thank you very much.
Yeah, thank you. The first questions you asked me about. So I answer so the second because I can remember exactly. This is the second questions. This is the I design a new algorithm to solve this problem the image on the computer from the computer design computer. The first phase we use Contourlet to enhance, and the second we design the unit. This is different deep learning to segmentation the image. The second phase we must to design more about algorithm to locate where is the abnormality. So as you know, it is this resource. This the third phase in this problem. You can search in the internet. We publish more about 4 or 5 articles. Yes, this is now. We would like to make it better. In the past, the last year, we designed a different method. Accuracy nearly about 87%. It's now we hope it is more exactly. Thank you.
Okay, so good afternoon. It was interesting what you're presenting. I just want to know, because to follow up on the questions on the 3D and 2D, right? So your existing methods, is it already can do for the 3D approach? And if it's 3D, are you still using the same segmentation approach that you use for the 2D?
No. If we use the data is 3D, it's different from the 2D. Because if the 3D, if the layer in the first layer and the second layer is not in the same as the axis Z. Yeah, they move the axis Z in the space.
So what segmentation do you use for 2D and what segmentation do you use for 3D?
So I think it's my opinion, we must to adjust the chase is the axis. We can use 3D unit or 3D CNN to solve.
So you haven't applied on 3D yet?
Yeah, not yet.
Okay. I think there's an area that we can actually talk about.
Yeah.
Okay, with that, I think that's all the questions we have. Thank you so much.
Thank you very much.
We will now move to the third presenters for the title of AI-based control of lower limb rehabilitation device for elderly people.
Assalamualaikum and good afternoon. So I'm Asnu Juraiza Ishaq, and here is my committee member, where Prof. Wada from Kyushu Institute of Technology, QTech, and Dr. Wan Alia from the Faculty of Medicine. And the others member is Dr. Azura, Dr. Mamahe, and Saomi Shin from same department with me, which is under Department of Electrical Electronic Engineering. So this is my proposed title for the future research, which is AI-based control of a lower limb rehabilitation device for the elderly people. So currently, I'm is a research fellow under the My Aging, which is under UPM. We have a Center of Aging, and then we have opportunity to gain the data and do the collections by helping from the director of My Aging and also Dr. Wan Alia. And here is outline. Before I go further on the proposed method, I would like to discuss about the my past research, okay, and also the current research, where my past research on the ankle rehabilitation device also, and this is focusing on the signal processing, okay, pattern recognitions, and then the EMG system we managed to develop by ourselves for the My Aging Center, for the use for the postgraduate research, and then under the ankle rehabilitation, we just a minimal use AI method for type of motion, okay, for the ankle motion, which is dorsiflexions, plantar flexion, adduction, and also the abductions. And then we move to the current research, which is we currently manage to do this one, focusing on the development, knee rehabilitation development. As you can see that we're not integrated yet the EMG signal, force signal, and then the monitoring that we managed to develop is not real-time data. We need to calculate the power of the signal from the EMG signal and also the force, and then we transfer it to the system using the cloud server. So this is our futures research that we like to propose, where the ankle, the knee rehabilitation device will be integrated, combined, and we want to control monitor the motions, the improvement of each motions based on the EMG signals and also the force signals by applying the AI method. Okay. So the background of the studies or the research, it measured the percentage of elderly populations aged 65 and over, increased from 7% in 2020 to 7.4% in 2021. So elderly population have problem in neurological disorder and chronic disease. So as you can see that in Malaysia, the population for the elderly is increasing. And then because of the knee pain by traffic incident, osteoarthritis, and also the ACL strain or tear. So non-surgical treatments such as the physiotherapies or exercise are first recommended to knee osteoarthritis patients before opting for knee replacement surgery. So and then the joint stiffness and decreased knee range of motion have been reported following surgeries such as total knee replacement, ACL reconstructions. So therefore, the range of motions. Exercise is crucial in treating knee arthritis and also the relieving stiffness after surgery, restoring ROM, the range of motions, and improving muscle strength of the patients. So the target of the research projects is develop an intelligent control of the knee rehabilitation device for improving the range of motion and muscle strength of patients. So this is the futures or the proposed that we plan, okay, where it cover under the objective 3, okay, objective 3. So the first objective is to investigate an EMG based and force control for analyzing human disability and observe the improvement of the rehabilitation processes. And then to develop a rehabilitation device, this one we done, okay. And then to design an effective control using a intelligent method for identify the unique EMG pattern and also the force pattern. So this is ongoing, okay. So the methodology or the proposed method. So the first one is stage 1, which is data collection and characteristic of neurological disorder, EMG and force signal, where currently we have the ethical approval, EMG and also for the ECG. So it will expire, but we will communicate through the Faculty of Medicines to apply for the next projects. And then this is the flow for the signal processing method. So we need to go further with the pre-processing, which is for the enhancement of the data, windowing, feature extractions, feature reduction, which is for the feature selections, and classification. So for this moment, we minimal apply the AI, but not really done yet, because we are focusing on the development of the knee rehabilitation device. So the stage 2 is model simulation and fabrications. So we managed to design the knee rehab device by using the AutoCAD, and we did some simulations on the types of motors and also the gear. And okay. And stage 2, model simulation and fabrications, where after we design the mechanical, the structures of the knee rehabilitation, we need to do the simulations in order to test all the joints and to test the motors, and also to make sure the motor run properly based on our speed, target speed and target angle. So we need to have a good control there. So and then we propose for the current research, we use the PID to control the speed and also the angle for the knee joint motions. And therefore, okay, we need to do the further works on the future work 1, where we need to have an optimal gain. We can use the optimizations algorithms, or we can use the fuzzy logic and so on. So for the, and then for the, from this one too, we can propose for the second future works, where we can do the mapping or compare the previous EMG signal before the training started with the current EMG after the first trial or the several trial to control the motor speed, because we need to know the improvement of the muscle. So that's why we need to have a comparison between these two EMG before and after. So, and then stage 3, control development, EMG, force control system and intelligent method. So this is under the futures work 3. After we gain the signal, okay, we need to do the signal processing and then windowing, okay. And then from there we extract the features, okay. And then we apply, that's why we want to apply the force signal and EMG signal, and then we calculate the correlation, and from there we can do the real-time data monitoring system, okay, for the future work 3. So the output is the monitoring system. So the currently that we managed to use the we managed to display the bar chart, but this one is not the real data monitoring system. We calculate the EMG powers from the EMG signal, and also the angle from the knee and also ankle joints. So that's why you can see only the bar chart there, okay, instead of the signal. So, and then the impact, the EMG-based control can be implemented on rehabilitation device or the therapy machines, and trainer tool to new therapists and host and health officers. Open EMG database offering different kinds of lower limb joint motion, which is covered for the ankle and also knee. Decision-making system with AI implementations. So the conclusions, so this is the conclusion that from the current research achievement. So knee rehabilitation device was designed and selected. Control system was designed based on the PID control. And also we also did the experiment and tested were carried out. And then the simulations, again, the simulation for the PID controller design in MATLAB result, we finally find out that the low overshoots and zero error between the set value and the actual value. Okay, and then the future improvement is based on the future work 1, future work 2, and future work 3 that I've been explained before. So this is my plan for the connected projects: medical data signal and data analysis, which is cover the signal processing and also the image processing, AI-based control development, healthcare monitoring system, actuator rehabilitation applications. So thank you.
Okay, thank you. We welcome questions from the floor. 3 minutes.
Done the past research, right?
Yeah.
Yeah. Okay. And then now the stage is how many percent now?
On the development rehab knee device, okay, knee device, we already complete, okay. This is our controllers on the right side, but without the AI. And then we have a force sensor EMG signal been also done, and then we done the knee rehabilitation device also, but without the AI.
So based on the results, any university, hospital, university, work together with your project.
Okay, so far is Dr. Wan Alia. Dr. Wan Alia is from the Faculty of Medicine, where we from the HP UPM, Hospital Pengajar UPM. So we have a Hospital Pengajar UPM. So that's why in ethical approval, we not very difficult because we know the pattern, because this is my second time apply for the ethical approval.
So I would suggest for you to involve industry, so that and users, finally, and then you want to commercialize this, for example, we need industry to be part of the work. Okay, thank you.
Okay, thank you.
Okay, any more questions? So maybe I just ask one. Since a lot of work has already been done, you're just talking about missing the AI parts to go in. So maybe one of the plan you could have is to do some benchmark with those equipment out there. And maybe we are targeting some low cost, which is more affordable. Yeah, maybe some thoughts along that line.
And also friendly use.
Sorry?
Friendly use.
Yes.
One, yeah.
Yes. So a benchmark on that will be very useful.
Yes,
with those in the industries.
Yes. I have a question.
Yeah. Okay.
Yes.
Please.
So yes. Okay. Thank you very much for the presentations. To the best of my knowledge, your objective is to develop an intelligent control, right?
Yes. Yeah.
Yes. And then in some slides, you saw that the feature extractions is based on time and frequency. For the case of based on time, maybe it is easy to understand, but would you please explain what is the feature extraction based on frequency?
Okay.
Okay, and then the second, would you please explain what is the difficulty of this control system, and then what is the connection with the EMG? Because I cannot get from other presentation.
Oh,
Thank you very much.
Okay. The first one, the first one is related with the pattern recognition, based on the time domain and frequency domain, right?
Yes.
So the time domain, as you can see that this is where my previous here on all the time domains features. And based on the frequency domain, that's why we not manage explore yet, okay? But as I can suggest that we can apply the like the convolutions method for the frequency domain, and which is under the CNN, and also for the second questions related to.
Yeah, what is the difficulty in this design?
Okay.
Yeah, and then what is the connection with EMG signal? Yeah.
So so the difficulty on to control the monitor the speed of the motions for the knee and ankle motions, because every treatments that we example that like knee ankle that we did, so we have 10 sessions or 20 sessions based on the difficulty of their joint. And let's say 10 sessions. So the 10 session we need to control the angle. So control the angle and also to control the speed. So to control the angle and control the speed by manually difficult to monitor. Okay, and then we apply the PID. So then we can map their pattern, the signal pattern from the EMG. Okay, and the force, whether they have how many different percentage. Okay, so that is the difficulty. So why implement the EMG? So the EMG, as you can see that here, EMG signal before and after. Okay, we want to do the mapping. So the first treatments, we can see that the strength of the EMG signal is very low, weak. Okay, so and then how is the improvement for the second after we apply the therapies based on we already control the speed and the angle. So the pattern there, whether EMG signal or the force signal should be increasing same level. Why I explore the EMG and also the force sensor, because of the, let's say that example just now about the industry, we want to see which one is sustainable and also the very low cost. Okay, so as from my opinion that force split, we apply the force split for the minimum angle that should be fine compared to EMG.
Okay, thank you very much.
Okay, thank you. I think more discussion can continue after this. Thank you so much. This concludes the sessions 5. We have 2 more to go.